And welcome to the Tampa Data Analytics Meetup. How many people are here for the first time? All right, so a good number of you. We've been meeting every month for a few years now, I guess since coming out of COVID. We just keep growing. The group in Tampa, we have a lot of analytic professionals that, are excited to get together every month. And this is member driven. I am a professor at USF. And so I sponsor the event and buy the food because I just say a couple words about our program. We have a Master of Science in AI and Business Analytics. And so if you're interested in data science and AI and want to find a program to get a STEM certified graduate degree on the weekends, so for working professionals, please reach out to me. How many folks have been through the program or currently in the program now? You can talk to one of those folks who are now making millions of dollars because of this degree. Eventually, like they're accumulating millions of dollars, just maybe some slower than others. But anyhow, in all seriousness, please talk to me if you're interested in gaining some competency that is very, very marketable right now. So Stacey's here to talk to us about LLMs. He's been a member, I guess, since I've been hosting this, and has spoken before and been fantastic sessions. And any questions before we get going? No, it's all yours.
Hi, good evening, everyone. So today we're going to talk about setting up a private instance of anything LLM, which is going to be your front end, and Ollama, which is going to be your LLM back end. So about me, I'm a data scientist at USCENTCOM. I have a bachelor's and master's in computer science, master's in data science at SMU. So we're going to the not the championship, but playoffs about a week and a half from now. So excited about that. I relocated to Tampa in April of 2022. The history on that. When COVID happened, I was trying to find a place to move to. First, I was looking at Austin, Texas, as I kept hearing good things about Austin. And I came here and fell in love with it. So I decided to relocate here. My hobbies are motorcycle riding, hit high intensity interval training workouts, and Krav Maga, which is like martial arts, self-defense, and actually sore right now because yesterday during training, I had to close my eyes and had to be attacked multiple times from behind, like chokes, ropes, and you have to react to it. So it trains you for every type of self-defense. And so the first part, we're going to talk about anything LLM with Ollama, with the large language models, with the different technologies. That's part one. Part two is going to be next month. It's going to be very exciting. It talks about AI agents, and the framework I'm going to use is Crew AI. You have different frameworks, but the one that I like and is used by a lot of Fortune 500 companies is Crew AI. So, introduction to anything LLM. It's a versatile full stack AI application that allows seamless interaction with documents using various LLMs and vector databases. So I'm going to explain all of these different concepts with the vector databases. I'm going to talk about not much about the AI agents because that's going to be next month. And it's good you have like your own private GPT type interface. So if you have like private data that you do not want to get out in the public, then this is going to be the solution for you. The key features of anything LLM. So I can read the slide, but it's better to go to here. So this is the actual GitHub for anything LLM. It's totally open source. And you have the different releases for it. And you scroll down and it gives you information about it. and it gives you like a demo of what the front end interface looks like. And here it gives you all of the features it tells you. So you have, like, for example, you can create your custom AI agents. You have multimodal support, multi-user instances. And so you can just go to it and read all about it. It tells you about the different models that it supports. So OpenAI is one, AWS Bedrock, Ollama, which we're going to talk about, Hugging Face. There are many models that are supported by. You also have audio services. You have text to speech. And then you have the different vector databases, which we're going to talk about. The one that is, your default one is going to be LansDB. That's the internal vector database. A popular one, the popular ones here are going to be Chrome, Pinecone, Weaviate. You hear a lot about that. Then also on the demo, I'm going to run it on this laptop. But if you want to, you can run it in Docker, AWS, Google Cloud Platform, DigitalOcean. And that's usually if you're going to have multiple users, you're going to have a like a production environment. And that's when you want to have a cloud platform. And then I pretty much talked about all of the different supporting models and technologies that we have with it. It's a technical overview. This is more important that if you're going to take the open source code and make changes to the code yourself. So you have access to make changes to the code if you don't want it to work out the box from the open source code. Now, one of the biggest questions is like, when do I use the desktop version and when do I use the Docker version? Well, the easy answer for that is if it's just for you, just playing around with it, you want to test it out, just use your desktop. But if you want to have multiple users, if you want to have like an admin user, a manager user, and also you would have just regular users, you would have a Docker version, and then anyone who knows about Kubernetes, you can deploy it into Kubernetes also. And so real world use cases for anything LLM. You implement anything LLM to create private knowledge base for internal teams. As I said before, if you're like a hospital clinic and you have PII data that you don't want to get out because you don't want to ask a question about patients and have it go into Chat GPT and get that information out, then you have to have your internal LLM infrastructure going. For customer support automation, this part is going to be more for next month, but all of us have had the issue where, let's say if we talk to customer support, if we call a bank a hospital and they say like, press 1 for this, press 2 for this, and it takes forever just to get your answer. You know, you want to press 0 just to talk to a person. And so it's frustrating. And then you press the wrong one, they slap your hands, and you got to start back over. So, and so this will solve it because you can say like, this is my issue, this is what I want to do. The great thing about agents is that instead of putting you to the right personnel, it's going to solve your issue for you. And that's the great thing about agents. And then also case number 3, document analysis and research. That's what we're going to talk about tonight. So the introduction to Ollama. So, I mean, I can read this boring slide to you. I guess I can just take it to GitHub. So Ollama, they have their own GitHub. And you can see the different releases here. And you also have access to the source code. And so here you have like the Docker version. Here are different commands where you can run it. So when you put down a model, you can see Ollama run. you have your different models. So this one just came out, the Llama 3.3, which is the 70 billion parameter model. It is equivalent to the Llama 3.145 billion parameter model. And on this laptop, I can actually run a 70 billion parameter model, but it's slow. To get efficient speeds on this laptop, I could have to run like a 7 billion, but 14 billion I can run on here. But if you're trying to run something that's like 70 billion or greater, you're going to need some powerful machines, cloud infrastructure in order to run it. But here are a list of all of the models that we have here. If you're in like in a closed environment, so say for example, if you don't have access to the internet, let's say you're in a secret network, a closed off network, you may have to load it manually. And so here are the instructions to load the model. So it gets you up and going. And so I can bring up. So here, I actually did I have a Llama running right now. So if you want to see what is local on your machine, I just ran like a Llama list. And let's say, for example, if I want to run a model, let's see, Llama. I'm going to run a simple model. I like the Queen 2 model. That's the model that was created by Alibaba. And it gives, for the size, it gives a great performance. So I say run, it's loaded. So I can say, tell me the history of Ybor City. And so you can run it directly inside your terminal, and it gives you the history. So now if I want to exit out, just hit Control D and I'm out. And so my models, you can pull them directly from command line. And so this is how I run it inside the command line. Now next, I'm going to give you like an overview of the vector databases. So the vector database, you know what, instead of putting you all to sleep, once again, I'm going to open up a Jupyter notebook. You want to see that?
I love Jupyter.
Yeah. So even though it's not exactly Jupyter, it's through VS Code, but I say like Python notebook. And so from this notebook, I'm going to talk about document vectorization and storing into a vector database. And so what is vectorization? In simple terms, vectorization is the process of converting text data into numerical form so that a computer can understand and process it. And so the only thing a vector is, it's a list of numbers that represent information. And in our case, vectors represent words or documents. The vectorization process turns words or sentences into mathematical representations. So think of translating language into numbers, which allows computers to search and compare the meanings of different texts. And so why do you have to vectorize? So it enables text similarity. Find similar text based on their numerical representation. Search and retrieval, you can quickly locate documents relevant to a query. And then you have clustering and categorization. So group similar text together for analysis. And so here's some Python code, and I have a sentence transformer, and I download the sentence transformer model, which comes from a Hugging Face. And so say, for example, if you have the sentence, artificial intelligence, and you can read the rest. And so it breaks it down, breaks it up to 3 sentences. So the first sentence, artificial intelligence, is fascinating. The vector embedding representation is going to be here. But so you see 1, 2, 3, 4, 5, 6 vectors. Well, it's just not 6 vectors that represent this sentence. It's actually 384. So it's concatenated. So it shows you how much the vectors represent just this one sentence. So then, let's say we have some more sentences that we talk about Tampa Bay, we talk about Gasparilla, we talk about Ybor City, the Hillsborough River, and then one, to throw it for a loop, we have the Grand Canyon. And so we understand sentences through semantics, but the computer understands it through, I say, like similarity. So for example, you have like 2 vectors. So for this instance, we have cosine similarity. And so we want to see how are the sentences similar. And so for example, we have sentence 1. Well, of course, sentence 1 is going to be an exact match to sentence 1 because it's the same thing. And so the lighter the color, the more similar the sentences are to each other. The dark color means there's not much of a relationship. So if you see the very last sentence, sentence 5, you see how dark the color is because there's not much relation to hiking through the Grand Canyon in relation to the rest of the sentence that deals with Tampa Bay. And so then, so now, let's say, for example, if we ask a question, what are some popular activities in Ybor City? So now we have to find a match. And so a perfect match is going to be 1. No match at all is going to be like 0. And so it finds the closest sentence that matches with the question. And so you have the first one, exploring the bustling Ybor City at night. And you have a 0.6. So you have a 60% match. And so it's going to come back with this answer at the top. And so we just use one transformer, the one through Hugging Face. The text embedding Ada, that's the one through OpenAI. And so the one through Hugging Face has 384 dimensional vectors. The one through OpenAI has 1,500 dimensional vectors. So that's why, for example, OpenAI gives you much better results compared to a lot of the free models, even though they are catching up with OpenAI and some one day may surpass them. So now we're going to test the performance of using the free model versus the OpenAI. And so I have like, I kind of made the sentences kind of more complicated to give the models a challenge. And in the very last one, I threw something off the wall. So Michael Jordan is the greatest basketball player ever. And so we have a question. Where can I enjoy both cultural heritage and scenic views in Tampa? And so you can see the similarity matrix, but this is the text form, but it's a lot easier when you see the graphical representation. And so based on the question, if we go just by the sentence transformer model, which is 384 dimensional vectors, it gives the highest rating to the first one. And then it goes down. But if you look at OpenAI's, it's very sensitive to, I won't say sensitive, but it looks at all of the nuances of the data. And so it takes a lot to really just make the percentage go down. But if you look at the sentence transformer model, if you look at the very last one by Michael Jordan, it's almost like it went negative. So you must think LeBron James is the best basketball player ever. I don't know. And so on the last one, we're going to talk about what does it look like when you store vectors into a database. So we have our sentence representation and what it looks like in a vector. So we have this first sentence right here. When it's inside a vector database, this is what it looks like. But it's not showing all 384 vectors. To see what it looks like, this is what it actually looks like for just that one sentence. And you store it inside a vector database. And so that talks about the vector databases. And
Stacey, can I just make one comment? Because I think you're hitting on a really important point, like that everyone who's trying to develop this stuff, the first thing that you're probably going to run into it as a decision point is how you're going to chunk your data. Because how you break up your data determines what your embeddings that you're showing ended up looking like. And so what I mean by that is you have an article, right? And one article in Confluence or wherever about Tampa, right?
right.
But based on what's in that article, there may be information about Ybor City, there may be information about, whatever, St. Petersburg also in that article. And if you chunk it all together inside one embedding, if someone asks a question just about Tampa, information about St. Petersburg may show up in the answer, and that gives you a hallucination, and that gives you potentially an incorrect answer. So one of the first big challenges you're going to have is how do you break up your data to start your embeddings?
Okay.
So,
you know what? I had a dream that you were going to ask me about the question. So I got it right here. Check chunking and split. All right.
actually, you paid me $40
Yeah. So to answer that, I can go over this, but I have another Jupyter notebook on it. All right. And that one talks about text chunking and splitting. So why is text chunking and splitting useful? So like you say, like when we deal with large text, like articles, reports, books, it's often necessary to break it up into like smaller chunks. Why? Because it improves processing efficiency. Then you can store chunks as individual entries into a vector database. And it makes retrieval faster, more accurate, and you can focus on smaller topic-specific segments. And so here, we're going to stick with the Tampa theme and give some examples. So here we have our text. Let's say this is like a magazine article. And so let's say, for example, like I like pizza. Well, I can't eat the whole pizza by myself. So I gotta like slice it up and split it. And so that's basically what it's doing. So we split it up into sentences. So this here, if we have it split into sentences, this is what it looks like. So this calls splitting. When we chunk by word count. So let's say if we want to have our max words equal to 20. And so what it's doing is chunking into 20 words. But as you see, it's not doing it by sentences because it breaks it up. And then you can chunk by character count. So the character count is 100. And so it goes by 100 when it splits everything up.
How do you decide which method to use? Which method is best for you use this?
a lot of it is kind of like, you have to just play around with it. Yeah, it's kind of hard to find.
Yeah, we found like it's experimentation and then figuring out where you have data gaps.
Yeah.
Because some things may be able to make into bigger chunks. And you just have a very well-written article about Tampa, it's great. And you may have another article about St. Petersburg that's not very well written, and there's a lot of pieces missing. And so you may have to fill in the gaps rather than just trying to figure out where to chunk it.
Yeah. And so here, you just take the chunk and we're doing embeddings like in the previous notebook, we did the embedding, so that's the same thing, nothing different. And then there's something called text chunk with overlap. And so what overlap is, we have, it's a serene experience indeed, but it's overlapping with the second chunk. That's because there may be some information that goes from one chunk to another, and we don't want to miss out on that. So we have overlap. And so overlap, there's like no magic number. You just have to play around with it for you to get the best results. And so here I just have generating and displaying embeddings for each chunk. So all this is just a vector embedding for the chunk.
Is there an optimal amount to chunk? Like, for example, right, you're doing ML work.
Mhm.
There's a certain percentage you want for your validation, a certain percentage you want for your test. Is there a rule of thumb of like, okay, chunking every 3 sentences or chunking every paragraph or chunking each sentence?
I guess it depends on like performance. You kind of want to find like the best method. So usually like when I chunk, and you'll see in the example, I use like 1,000.
Mhm.
And then I have my overlap at like 200. And the best answer for that is just to do your research to see what someone else has done.
Yeah.
And then just play around with it to see what kind of answers you'll get back. And then a lot of it depends on which model you use. So you have some models that do better than others.
So like, since open source models don't perform always the best, as like, well, they're getting close, like you
Yeah.
said, close to closed models, right?
Mhm.
Would you say like, okay, for open source, you don't want to chunk too much and do it like maybe by sentence or every 2
Mhm.
sentence, or
No, you don't.
want to just throw it paragraphs, or what would you throw at?
I would throw, well, I have a set.
I'm just taking an article, not like a whole.
Yeah, like article, right now, I have it set at like, it's 1,000. I forgot, is it like words, sentences, but I have it set at 1,000. And then I have my overlap set at 200. But I'll explain it in the demo. You see my settings, or what I have. Oh yeah, so here's the next one. I had a dream you asked me about the red also, so I got an answer for you. So I can give you this boring slide right here. I guess I'm gonna go back to it, and I'm gonna talk about how we can explain it with the librarian example. Then I'll come back to it. So say, for example, you ask a librarian, can you tell me about the history of Ybor City? And so now, the first part, you have the retrieval, which is red. So the librarian goes and retrieves a book on Ybor City about founding as a cigar manufacturing hub. But the librarian also retrieves a recent article about Ybor's modern revival as a cultural and entertainment district. Now for your augmentation, the librarian augments the historical data with modern updates. And so it talks about the history of Ybor, but also it augments what's going on right now. And so that's your augmentation. And then the generation part is where the librarian summarizes and simplifies everything for you. And so it generates a clear, concise response tailored to you. And so it augments the history, what goes on today. So if you go back to retrieval augmented generation, all it does, it combines and retrieves and generates to enhance the performance of AI models. And so basically, let's say I'm a clinic, I'm a hospital, and I want to ask some information about patient data. Well, it's not going to know about a regular model. ChatGPT don't know this information about this patient. So that's when you have the information that you put inside a vector database. And so that's your RAG part. So the R, it retrieves that information, then it augments the information about the patient, but also what it may know in the real world, and it generates something for you. And then it gives you a clear, concise answer based on that. So that's basically what RAG is. And that's the answer, because a lot of times people ask, like, can you like train a model? Let's say if you have a model, a regular model, but you want to train it based on your cognitive data. I mean, you can do it, but you have to have a lot of GPU horsepower in order to do that. The answer is this. If you want to know answers based on internal data, you use the RAG, retrieval augmented generation model on that. And so that way you don't have to retrain a model that you already have. And then, so here's like an overview of how anything LLM works with the different models. So I can use my cursor, I'm gonna go here. So you have anything LLM, and so you have your embedder. So we already talked about the different embedders. There's one here, the anything LLM, they have their own embedder, or you can use one that has OpenAI. Once you embed the model, it's stored inside a vector database. So LansDB is the vector database that is internal to anything LLM. And then say, for example, if you want to have your own external ChromaDB database. And so this is one. So then next you have your different large language models. So everyone knows about OpenAI. They have their different models like GPT-4 or 4. And Ollama, they have like many models that you can choose from. And then one thing I forgot to show you was the number of models that you can find. So once you go to Ollama.com, you click models. And so these are all the models that you have, like many of them. And so you can go by like the popular, you can go by the newest. Here are the different embedding models you can use. And to know which one is better, you have to play around with them. From my experience, I would say the Nomic embedding model has done best for me for like a free embedding model. And then you have different vision models that you can create. So, you know, with OpenAI, they have like the Dolly, and this is like the Dolly version, which are free. And then you have different tools that you have. So I wanted to show you that. But going back to this diagram, it just talks about the different models, even with Azure. OpenAI, they have their models. XAI, they have their own models like Grok. And so next, I'm going to go into the actual demo and talk about the front end of anything LLM. So this is what it looks like, the front end. And when you go to your settings, you have your different AI providers. So here, the default model that I chose was Ollama. And these are the models that I have loaded within Ollama. And so you could choose the one you want. You can set your max tokens. So I have the max tokens at 10,000. That's the number of tokens it's going to bring back for your answer. And if I wanted to, I could have chose like OpenAI. And so with OpenAI, I had to, you had to have like your own API key. And then you can choose all of the models within OpenAI. And so this charges me every time I bring back some information from OpenAI. It's a cost, but it's not that much. I mean, unless you're just getting like this a huge amounts of data. And so then if you go back to Ollama, it's talking to my computer. So this is the port here. It's 127. The URL plus the port. And to see what it looks like when I put it inside my browser, it's a test. So it tells me Ollama is running on my machine. So that's how you know it's running. So the next one, they're going to be your vector databases. So as I said before, the one I'm using now is LanceDB. So that's the internal database. You have Chroma, Pinecone, and there's many more. And then you have the different and better models that we talked about before. Yeah. That answer you asked about the text splitting or chunking. So you have to play around with it. And so right now I have it set to 1,000 and the overlap is 200. Then you have your voice and speech. So you have just many different, well, yeah, you only have local whisper. So you have that one, then you have your transcription models. You have admin where you can ask different, it gives a history of the questions that were asked. Then you have your tools. So when we go back to the screen, you have different workspaces. So I have some sample documents. And if you look at the workspace, like for example, if I open this one up on the settings, that's the name of it. You have your chat settings. And I want to go over this. So you have chat mode. And so if you want to know the answer, you don't want it to hallucinate. I try to eliminate the hallucination. You put it in query mode and not chat mode. So if it's not in the documents, then it's not going to bring you back an answer. And so the prompt, this is just a generic prompt out of the box. And then another thing to look at is your temperature. If you don't want it to hallucinate, or lessen the chances of it, you set it to 0. But for this workspace, I created my own prompt because this is based on a legal professional. So I say like, this is a prompt for a disability report, and it's going to get information about the patient. And so this is supposed to create a report to try to get this person a disability claim. And then the next one is for a healthcare provider. So you can have a workspace based on the answer that you want. So say, for example, you don't want to have it in a prompt every time you ask the question. It knows. So all you have to do is throw the person's name in it, and then it will give you the report that you want. And here, the vector databases. So you have the max context snippets. So the default is to 4. And that's basically, I think, the amount of documents or context it's going to look at. That's what that is. Yeah, you can have the document similarity report. So I have it set to 50% because I don't want to miss out on important information, because sometimes it only brings back 60, maybe a 65% confidence level. But if I was using OpenAI, I can have my similarity score set high because it's very accurate. And then the next one is for agents, but I'm going to skip this because this is going to be for the next talk. So to understand, I want to show you what this documents look like. So here's a sample document right here. And the person's name is Raleigh Jones. And it tells you about their background history. And so we're going to pretend like this is like a clinic or whatever. And so we have information on this patient. And so we found out this person, they have some issues, and we're trying to get this person some disability. So you have your legal professional. And so we asked it, so I was testing here because I wanted it to see like if Mickey Mouse is not in the database, don't make it up to lessen hallucinations. So it's fine. So let's say Raleigh Jones. I'll just rerun this. So just save and submit. And it's actually running on my machine and creating this report. And all I had to do was just type the name. And so this one, I'm running the Quinn 2.5, 13 billion parameter model. When I ran the Quinn 7 billion parameter model, it, even if the name was not inside the vector database, it still wrote a report. So you got to have an intelligent model. The larger the model, the better answers you're going to get. So if you have like a production environment, I suggest use a larger model, and you have to have a lot of GPUs to support what you're trying to run. And so hopefully it will give an answer. Yeah, and then also the first time it runs, it has to load the model inside the GPUs. So the first time you run it, it takes a while to load.
One question I have, so if this runs on your local, right, let's say you are using an OpenAI API, right? And it saves kind of the chat history of the questions that it asks.
Right.
Have you experimented, or does anything LLM offer something called semantic caching, where like it's able to kind of take into account the most frequent questions? So that if you are using an API key, you're not running on cost, you're instead just kind of recycling past answers to answer previous questions that were asked before.
I'm not sure if it's using like the past answers. I think it's still going to go to the API to get the information, but it's going to remember information that you had said
But it's still gonna
before.
hit the API, like it's still gonna inquire cost.
Yeah. It's still going to inquire cost.
They gotta make money.
Yeah.
So
So like
that concept of semantic caching, like recycle answers so that it doesn't constantly get.
The only way you could do it is if from your orchestration
Right.
layer, if you're keeping that user session to say like, oh yeah, Joe Smith just asked a similar question, and you cache it on your side and return that response without any OpenAI API. You know what I'm saying?
Yeah.
Right? Like
Yeah.
you keep track of that prompt history and the user history in order to reduce cost.
And so this one is taking too long. So I'm going to change this model. You know what? I think it is running. I think it is running with OpenAI. Then also it could be the network speed. So I know the network speed here isn't all that great. So let's go back. Just another one So I'm gonna try the healthcare providers and see what happens. The default thread. Let me make sure which model is running. Oh, so this one's running Ollama. The first one should have ran. So I'm gonna try this one. So I thought I ran before. Let's run it again.
They're saying the API is down. It's been down for like 20 minutes.
Which
20
one?
minutes. Open AP, open AI.
Oh, it is?
Yeah.
Okay, it would be down during my demo. Yeah, okay. That's why. All right. All right. All right. Okay, that makes sense. So this one is running. Which one am I using on this one? Yeah, this is using Ollama. So it should. All right, I'll tell you what. I'm just going to put in smaller model that runs quickly. So the Quinn 2 latest, going to update it. Default. Jim Parker. And so for some reason, it's taking a while. Why, I don't know, but you can look at previous questions. This is one. So here's one, which is Carl John Smith. So here's the medical report for Carl John Smith. It gives the patient information, his name. It tells you about the date of birth, social security number. It gives you his medical history, current conditions. And I did not tell it to do all this. I just gave it like a prompt on what to do. So it's given like a recommendations for his treatment. And so for someone who worked in the healthcare provider industry and they had like multiple patients that they want to have a recommendation for in their treatment, instead of them having to go through all of them and having to take the prompt every time, just give them name and then they would just do it for them. And so they can have different workspaces for whatever they were trying to work for, and it may have came back from an answer. So it still hasn't came back with an answer yet, and then OpenAI is down, but you can see what it looks like on here. So do you have any questions? Any more questions?
So the prompt, I was just gonna ask for clarification on the prompt. So you said that it's not asking, you didn't ask it to generate that per se, but what is the role of the prompt playing versus your
Yeah.
queries here?
Yeah, I can show you. So if you look at, so this is like the default prompt. Let me bring this out.
So it's basically just a way to make it like an easy query to just
Yeah, to
be
format it.
used over and over again.
Yeah,
for someone. But then you can also ask general knowledge questions or not?
yeah, I can.
You can.
Mm-hmm. Yeah, I can ask
And
you.
always keep in mind, as you add stuff to your prompt engineering, that goes, and every time you make a call, that goes in against OpenAI. So there's a cost there. It's like an overhead cost every time.
Yeah.
So as you try to scale, and your prompts get more complicated, maybe as you build a better application, that's an overhead cost every time. That's hidden.
Mhm.
So
Definitely make sure you take a look at the input and output token cost.
right, because it may be a simple question. Why is Ybor a great city, but you have like 1,000, 2,000 tokens of prompt engineering before that, and it hits every time.
Context window.
Yeah.
Yeah.
Also, there are different model complexity and cost. So maybe you should use 3.5 instead of 4.0.
Yeah.
Correct, or the mini, they have the mini one out, right? So.
I can use for a simple chatbot, don't go and use 01 if you're just.
Well,
because.
correct,
Yeah.
You're right.
3.5 should be complete.
Yeah. Yeah, so things that OpenAI, the APIs down, because I just put text, it should bring back something. And so
If you have an Azure OpenAI key, that's up.
it is. Okay, now I have an Azure.
I tried to push something in the chat and it didn't, and I was like, that's, yeah.
Okay.
It took too long.
Yeah. And so
You got to connect. It's like, oh, good.
let's go back. So that's the answer to that. So ask questions. And so now I want to talk about what's next. And so for the next talk, we talk about the role of AI agents. So will AI agents take our jobs? Or will they enhance our productivity and free us to focus on more creative and strategic tasks? The new era of automation is to explore how AI agents transform workflows across industries by taking repetitive, time-consuming tasks and automate it with an AI agent. And so we're going to uncover the potential of AI to amplify human expertise. Or is it going to replace us? And so like join us for the next session where we demystify AI agents and their capabilities and how they can revolutionize your work. So that's it, unless you have any more questions.
So is it possible to maintain access control on the information as well? For example, not if, take a hospital system, not if it's a single system, but a doctor needs information about patient, but whereas the finance office doesn't need to know the information about what's happening to the patient, but rather just his payment details, maybe address and insurance details. So is it possible for us to maintain an access control on the vectorized data?
Yeah, you can.
So for example, if only the finance department is asking, it doesn't bring up the context from the patient's personal data.
Yeah, so I can show you. So when we set up and let's say I have like a new workspace. And then let's say doctors only. And say save. And then we want to have some documents. So let's say we want to bring up just patient data. And move it to the workspace. And so now it's in a workspace. So this is what takes those documents and you save and embed it. So now it's been embedded already, it's been vectorized just that fast. And then now, since this is the desktop version, if this was the Docker version, then let's say if the doctors, let's say if you had like the nurses, you can have it where, I won't say nurses, let's say it could be finance, and you don't want them to know about patient health records. You can have it where only doctors and nurses can only see this workspace. And so anyone else, they can't see this. And that's how you put control that, because the patient records are only inside this workspace. And say, for example, if you ask a question, I'm not sure what's inside. Let's see what's in those documents. Ask a question. Okay. So here's one patient. Let's see if it brings back an answer. Yeah. Yeah, so the issue is it's not coming back with it, so. and then open their eyes down. But in essence, it will bring back information about that patient. And then you can also do like prompt engineering. Let's say if you want to have more information, or you want to concatenate with more information, you can set it in the prompt. And so that answers. Does it answer your question on that?
Yeah.
All right, let's give Stacey